Hi everybody, welcome back. So today we'll move on to topic 8, and topic 8 is called Human Systems and Resource Use. In this video I'd like to just concentrate on the topic of human population growth. Hopefully I can keep it brief, but it's a very big topic, so I've tried to cherry pick what I'll actually talk about in this one. Basically, if you talk about human population growth, you're talking about this graph. This is a hockey stick graph for obvious reasons, very flat with a very big bend at the end. Hockey stick graphs are very common in environmental science. You're equally likely to see a hockey stick graph when we talk about climate change, temperature change, carbon dioxide release, because of the effect that humans have had over the last 100 years or so. And it's no different with population change. You can see this goes back about 12,000 years. For most of human history, the human population was not only very small, it was very stable. And then at the turn of the 20th century, we get this huge, rapid increase. We'll come back to that later. This is a good point at which I should say I've been making a few of these videos now, and I've kind of realised it's a lot of information from me. It's not particularly interactive. So what I'll certainly start to do with this one is I want you to pause at certain points, and I'll put questions on the screen, and I want you to give considered answers to specific questions before we move on. Okay, so let's, as usual, we'll go to the syllabus. Now, as I said, I've cherry-picked these bits that I'll talk about today. There's much more to human population growth than these 6 bullet points, but I'll try and cover certain parts today, and things like statistics we'll do a separate video about. So very quickly, in terms of population change, the syllabus says, in terms of knowledge and understanding, you need to know that human population has this kind of graph behind it. It's a rapid growth curve, and we need to consider how it's going to change in the future. You need to know that as human populations grow, certain stresses are going to be put on Earth systems and natural capital. And we need to consider how these changes in population depend on things like culture, history, religion, social aspects, politics, and economics. There's quite a lot there, even though I've only chosen a few small topics to cover today. This is probably a good point at which I should also say, in this topic, it's very easy to generalize. We look at a lot of interesting case studies, but please don't fall into the trap of thinking that every LEDC has the same issues, the same problems. Every MEDC is the same. For this topic in particular, I'd like you to be very careful about how you use your case studies and make sure you understand the details of the case studies you're using, specifically for essay questions on the exams. Please don't generalize. Very quickly, in terms of applications, it's fairly repetitive actually. So we need to discuss human population growth in terms of growth models. Specifically, I'll discuss the United Nations human population growth models. We need to explain the implications and the nature of this rapid increase in population. And again, like I've said before, we need to be able to discuss the aspects that affect it, for example, religion, politics, economics. Okay, this is the same graph as you can see above my head. Hopefully you can see it a bit clearer this time. 12,000 years of human history. For most of that time, we don't have very reliable written records. Possibly that begins around the time of the Roman Empire, maybe the Aztec Empire as well, but those are only very specific parts of the world. So a lot of this is based on extrapolation of data, and in some cases, the fossil record and burial sites. But we do know that for most of human history, the population was very small and very stable, because it's fairly obvious that the death rate pretty much cancelled out the birth rate. So that means that for pretty much every person that was born in a year, one person died. So there was no increase. Around here, around the 1300s, you might see a little dip. I'm not sure exactly which one it is. That's because of the Black Death in Europe. That had a huge effect on population. And then around the 1500s, we have the introduction of the Renaissance and modern scientific thinking. And then the introduction of modern medicine. And the population increase around the turn of the 20th century, about the time my grandparents were born, not that long ago, was due to the widespread acceptance and application of modern medicine. So it's there's a kind of misconception that population increase must be because people are having too many children. That's not the case. Population increases not because more people are being born, but because fewer people in a year are dying. And it's kind of ironic that one of the great leaps forward in human thinking and human science, the application of modern medicine, is responsible for what a lot of people might call the modern population crisis. I'm not going to use that word actually, population crisis. Okay, this graph kind of zooms in to the end of the hockey stick. It begins in the 1750s. There's actually two graphs here, a line graph and a bar graph. The red line graph is referring to the right-hand axis, which is the same graph we've seen before, the hockey stick. It's the population rise year on year globally. I think the more interesting graph is the grey bar graph, which is the population increment. So the population increment shows you how, in this case, decade by decade, how that population is changing compared to the decade before. So you can see from 1750 to around the mid-1800s, the population was fairly stable but rising slowly. And then around the turn of the century, we have this huge leap in population increment. What's most interesting is that in the 1990s, we start to actually see a decrease in population increment, which means that although the population is still increasing in size, the overall population increment is decreasing. So in other words, population is decreasing more slowly. The red line leaves us to the modern day, which is around here. So anything ahead of, I'm recording this in 2020, is a projection based on population models. The total population at the moment in 2020 is thought to be around 7.6 billion people around the world. My dad was born in 1938. At that time, the world population was about 3 billion people. When I was born, I won't tell you when, 1970s, it was around 4 billion people. And today we've reached almost 8 billion people. So a big question is what happens in the future. So these bars here are projections into the future. We're actually around this point. The United Nations, based on, largely on these population increment data, which, by the way, you might want to consider where that comes from. I haven't included that question here. So I'll answer that question now. Population data basically comes from that national census data. So governments, every 10 years or so, do big surveys of their population to find out how many people living in various places around the country, and they use it for projections of how to base policies in the future. The United Nations collects that data, but you should be aware that maybe not all census data is reliable all over the world, and in some countries it's not going to be as reliable as other places. Okay, so the United Nations, based on population data, have come up with a model that says if population continued to increase at its current rate, this kind of exponential rise, we might expect the population to go above 10 billion. It might start to approach 12 or even higher, 12 billion people by the year 2050. The year 2050, by the way, you're going to be about my age. Okay, so that's the upper limit of the population projection. The lower limit in a different country, in a different colour, sorry, well, is what you might expect to happen if something fairly catastrophic happened to the human population, which is kind of strange saying that at the moment because we're currently going through a global pandemic. Hopefully, it won't get any worse globally. But you can imagine something like a world war, huge pandemic that we can't control. Population might decrease. The United Nations says to around 6 billion people, or somewhere between 6 and 7 billion people. The mid-range value, which is possibly the most reliable value, the United Nations says that they believe, based on these population increment data, the population will level out, and it will level out by 2050 at around 9 billion people. Now you can see there's a huge disparity there between 6 to 7 billion and going up maybe to 11 or higher. I won't go into that because I'm going to ask you two questions. Number one, how do you think the United Nations uses data, and what data to make these population projections? And number two, why do you think the United Nations has given us a model that has such widely different values from the bottom end to the top end? So you might want to pause that to give it some thought. And if not, I'll move on. Okay. I want to mention one piece of statistical data. We'll do a whole video on statistics later, but I find this the most interesting and possibly the most relevant to what we're talking about today, is the idea of total fertility rate. The total fertility rate is defined as the number, or the average number of children a woman is expected to have in her lifetime. This data is based on the CIA World Database, Factbook database, and it's split up by country. So you can see the countries in blue have a total fertility rate basically of 2 or below. 2 is important because if a woman has if a couple has 2 children in a lifetime, basically they're just replacing themselves. That's called the replacement rate. The replacement rate is actually 2.1, slightly higher than 2. That might sound a bit strange, but the reason is you have to take into consideration, unfortunately, that the sex ratio of boys to girls globally is slightly higher for boys compared to girls. And one question we'll be answering possibly later on that you might want to consider now is why that is the case. So you can see that MEDCs, largely in the Northern Hemisphere, fairly low birth rates. That includes the United States, Canada, Europe, Russia, and Australia. You can also see that the hotspots in terms of very high fertility rates are basically in Central Africa. And I did some research before making this. I didn't know this until just before I started making this video. The entire top 10 countries in terms of total fertility rate are all African countries. Number 1 is Niger, with an average of 6.79 children per woman per lifetime in that country. At this point, I was going to discuss this, but I'm going to, again, leave you a couple of questions. Number 1, why do you think African countries make up the entire top 10 in terms of total fertility rate? Go back to the syllabus and think about those factors we said before. And again, what factors lead to Niger being number 1 on that list? I'd like you maybe to do a little bit of research on Niger as a country. Consider its economy, its politics, its religion, and tell me why you think Niger is number 1 on that list. Just as an aside before I just finish off this video, when I started teaching environmental systems and societies, for years and years during that time, or just before that time, the number 1 country in terms of total fertility rate was not Africa, it was this country here, or not African country, sorry, it was this country, which is Afghanistan. And for years, from the 1990s onwards, Afghanistan had a total fertility rate of 7 or above. It was huge. The fertility rate started to decrease after 2001. And again, I did a little bit of research. It's now, I think, about 4.5, fertility rate of 4.5. It dropped considerably over the last 10 or 20 years. And that's related to the politics of Afghanistan and the Taliban losing power in Afghanistan. A lot of what you'll read about in terms of total fertility rate is how much choice women actually have over their own fertility. So you want to consider that as well. Okay, so just to complete this, a couple of summaries. So number one, in terms of population growth, the world's population is now thought to be around or slightly higher actually than 7.6 billion at the moment, certainly above 7.5. Although population is increasing, as I said before, the rate of increase is becoming lower, or at least we perceive it that way. And not only that, the total fertility rate across the world is decreasing. Now that's not to say it's decreasing in every country, but globally it is. In 1990, the global average was 3.3 children born per woman per lifetime. In 2002, the global average was 2.6 children per lifetime. I don't have more current data than that, but in 2002 it was still above the replacement rate of 2.1. Something that we need to consider, and I think it's worth doing a video separately on this, is in many countries, HIV/AIDS has a big influence on the death rate. We'll come back to that later. Okay, and in terms of, just very briefly, because we'll talk about this again in other videos, what's the impact of this increasing population? Well, I should have used the term natural capital. More natural capital is needed to feed, clothe, care for, transport, and certainly in MEDCs to provide entertainment for us. Natural capital used is much greater in MEDCs compared to LEDCs. So you could say that certainly in Africa, in many LEDCs, the countries with the fastest increasing populations still are using much less natural capital. Fertility rate is decreasing and overall life expectancy is increasing. In terms of life expectancy, I mentioned Niger before as being number one in terms of the highest total fertility rate in the world. The life expectancy in Niger is currently 61.6 years. In Uganda, which was number two on the list, it's 62.5 years. That's the average life expectancy. Compare that to an MEDC like the UK. The UK's current life expectancy is 81.1 years. By the way, there are other countries with much lower life expectancies. For example, Nigeria, I read today, current life expectancy in 2020 is 53.9 years. You might want to consider why that is. And just before we finish, I mentioned HIV/AIDS before. South Africa has currently, I've read, a HIV infection rate, HIV positive rate of 20% of the country, which is about 8 million people. So it can be expected to have a huge effect. And finally, one final consideration, globally, Social Security is not necessarily increasing in order to cope with this huge increase in population. Okay, I hope that made sense. Kind of amateurish, I guess, but I hope there's enough there to start considering human population growth. As I always say, take care of yourselves and your families, and I'll speak to you soon. Okay, goodbye.